Yeah. So today in session 11, we will try to cover type conversion, casting, which is nothing but type casting, and then arrays. Okay. Today we will try to cover one-dimensional array. If we have time, we will try to cover two-dimensional arrays. Okay, and see what are other types of arrays. Okay. So let's get started. So today's topics are what are type conversions, what is the type casting. So under type conversions, we have widening conversion, which happens automatically. Can you all hear me? Yeah. So what are narrowing conversions and truncations? Okay. Also, we will see what are automatic type promotions, and see are there any kind of like issues with the automatic type conversions. Okay, and basic rules of automatic type promotions, and then arrays, single dimensional arrays. Okay. So in our last class, we learned about variables, declaring a variable, identifiers, rules for writing identifiers, and dynamic initialization of variables, scope and lifetime of a variable, and method scopes. Okay, so we know that what we clearly know that now what are the scopes and what is the lifetime of a variable. Okay, let's get started with our today's topic. So what are these type conversions? So like when do we consider about these type conversions? Okay, say for example, we are assigning a whenever you declare a variable, you assign a value to that variable which is of type compatible. Okay, in the sense the value which you are trying to assign should be of same type in which you have declared that variable, right? For example, if you want to assign a variable 10 or value 10 to integer, you will just say in int I is equal to 10, right? But here what we do is we try to assign a value of one type. We try to assign a value of one type to a variable of another type. Okay, so what we are trying to do here, we are trying to assign a value of one type to a variable of another type. Okay, for example, we have a long value and this is an integer. Okay, so we are trying to assign a value of one type to a variable of another type. Okay, it can be, so these two are both are different, right? Int is different from, int is not equal to long, right? So both are of integers only, but this data type is different and this data type is different. Long is different from integer. Okay, so when we consider this type conversion, there are two things. Okay, so one is compatible types. Okay, if you have say for example, you have a variable, yeah, let us consider this one only. Okay, you have variable long value. Okay, and then you have an integer value. Okay, if the value is compatible with the type that we declare in this particular variable, in the sense it is of same group, if you can call that way. Okay, we have integer, right? Integers, ints, we have byte, short, int, and long. Okay, so if they are compatible, if the value is compatible with the data type, then that particular type conversion is taken care by Java. Okay, that particular type conversion is taken care by Java. Okay, so what we are trying to do here, if the value is type compatible with the variables data type, if the value is type compatible with the variables data type, then those kinds of type conversions are handled by Java automatically. Okay, so that is called as your implicit type conversion. Okay, that is called as your implicit type conversion. Okay, so like for example, here we are seeing like long and 10. Okay, long and 10. We are seeing long and 10. Okay, so this 10 is nothing but integer, which can be automatically promoted to long when you are trying to assign it to long variable. But this may not be the same. This may not be the same case all the times, right? Say for example, I want to assign byte b is equal to some value 128. Okay, the maximum value that you can assign to a byte is 127. Okay, so this may also be a situation. Okay, in such cases, the conversion, type conversion. So whenever we say type, right? Whenever we say type here, it always means data type. Okay, whenever we say type, it is always data type. So whenever we say type conversion, it is data type conversion. Data type conversion between what? Data type, you are assigning a value of one data type to a variable of another data type. Okay, so in these situations, okay, so this is an integer. Okay, or you can call it as a short. Okay, so this is a short or an integer, and this is of byte type, which is maximum value which you can assign it to byte is 127, right? So can you do this? You cannot assign this value to this particular variable, that is b, because it is byte type. Okay, so in such cases we have to, our programmer has to explicitly do a type conversion. Okay, from integer to byte, okay, that is called as explicit type conversion. Okay, that is called as explicit type conversion. So typecasting is nothing but your explicit type conversion, where a programmer takes care of converting the data type of a value and assign it to the respective variable. Okay, for example, here I have to typecast this to byte and then assign it to byte variable. Okay, okay, that is, we will see how to do that. We will see the syntax for that one. Okay, let's move on to the next one. So we saw like what are implicit type conversions and then explicit type conversions. So what are the things that we need to take care of, or we need to remember while we are doing automatic, or Java does automatic type conversions? Okay, so the automatic type conversion happens when it always happens between compatible types. Okay, it always happens between compatible types. Always you should remember. Okay, automatic type conversion happens between compatible types. Okay, so automatic type conversion takes place when when the below two conditions are satisfied. What are the two conditions? The two conditions are the two types, that is the source type, that is variable type. No, the source type is your value type. Source type is your type of your value you are assigning. Okay, and target type is your variable type. Target type is variable type. So the source type as well as the target type should be of same type. For example, you are trying to convert an int to a long, or short to an int, or byte to an int, or byte to a short. Okay, so that is called as, those types are called as compatible types. Okay, the destination type should be larger than the source type. Source type is your right hand side. It can be either expression or it can be a value. Okay, so the values type is called as source type. Okay, and the destination type is your variables type. Okay, destination type is your variables type. Okay, so what are the two conditions that needs to be satisfied for automatic type conversion? So both the types, the source type and the destination type, should be of same type, and then or compatible. We call it as compatible, not exactly same, but it should be compatible. And then the destination type should be larger than the source type. For example, byte to short. Okay, somehow it is getting arranged. Okay, byte to or int to short, or long to int. In that way, you can store, char to int. Okay, or double to float. We will see what happens when we try to store float in int or something like that. Okay, so these are called as your compatible types. Okay, so this, whenever you see that these two conditions are satisfied, Java takes care of the type conversion automatically. Okay, this is called as widening conversion. Okay, this is called as widening conversion or automatic conversion. Why do we call it as widening conversion? Because a shorter type is converted into a wide type. Okay, for example, int type is always large enough to hold your byte type value. Okay, so byte will be promoted as int. Promoted as int. So byte occupies how many bytes? Yeah, Abid is asking a question. So compatible. Yeah, you can call that as. So what Abid is asking is compatible same as same data type, and incompatible different data types. Okay, so we will see that one. Okay, so as far as we know, like compatible means, yeah, you can you can call that way. Okay, so compatible means integer to integer. Okay, whichever the different, I mean, integer is one particular group, right? There are four types of integers: byte, short, int, long. Okay, and you can kind of like, you can't convert. We are talking about automatic conversions right now, so it is like that too in compatible types. We are talking about widening conversion. So the right hand side, that is your target data type, should be larger than the source data type within the same group. Okay, that is compatible. So what you told is correct. If there are any other things, say for example, can we store a value of float into an int? Yeah, we will see that one. Okay, so whenever these two conditions are satisfied, we say that it is widening conversion. Java takes care of that particular conversion. Okay, so char type can also be assigned to an int type. Okay, we'll see an example how that value is stored, and then when we display what exactly happens. Okay, with what we say, with type conversion. Okay, I mean type casting. Okay, so there is other thing also. We saw like widening conversion, but there is also narrowing conversion. Okay, but narrowing conversion is not possible between compatible types as well. Narrowing is not possible between compatible types. That is without typecasting. Okay, we have to, what is typecasting? We have to do a casting of type, okay, conversion of type explicitly. Okay, we ourselves have to take care of this conversion of the data type from a broader data to a shorter data type. Okay, of variable shorter data type. Okay, this may involve what exactly happens. This may involve complete or partial data loss, but when the value lies within range of target, lies within the range of target data type, there won't be any loss of data. Okay, we'll see an example with for all these things. Okay, and then let us see what is incompatible types. How do you do incompatible type? Okay, so incompatible type is anything like in, so yeah, as I told in the previous slide, int type to byte type. Okay, that is incompatible because int has how many? How many bytes? 8 bytes. Okay, byte has how many bytes? Okay, so Abid seems to be active. So Abid says int is 4 byte and byte is 1 byte. Okay, so int is 4 byte, byte is 1 byte, so 8 bits. Okay, so whenever you have a value, right, in integer, it occupies 4 bytes. Okay, let us talk in terms of bytes only. Okay, it occupies 4 bytes. Okay, so that you are trying to convert it into 1 byte, single byte. Okay, so obviously there will be a data loss only when the value exceeds the minimum or maximum value of your target data type. Okay, so we cannot do this. I mean, Java cannot take care of such kind of conversions because it involves risk or it involves data loss. Okay, and as we saw in our previous slide, it is called as narrowing conversion, and it has to be done explicitly by the programmer. Okay, not it can't be taken care by the Java. Okay, that is the rule. Okay, so what we can achieve by how we can achieve this narrow conversion? So we can achieve this by by doing what is known as typecasting. Okay, what is known as typecasting. So what is this typecasting? It's simply an explicit type conversion from one type to other type. That's it. Okay, how do you do that? You specify the target type. This target type is the type of your variable. Okay, target type is the type of your variable, and this is the value. This will have this data type, different data type. Okay, different data type. Okay, lot many people have answered this one. So regarding the bytes, okay. So how do we do that? This is the syntax for explicit type conversion and typecasting. So how do we do that? Say for example, you have byte b is equal to some value, some say assume that you have integer I is equal to 100. Okay, integer I is equal to 100. That way, how will you do that? Byte of 100. Okay, so we'll see that in an example. Okay, so here we have to specify the target data type and within the parenthesis. Okay, this we should not forget. Okay, what we have to do? We have to put that within the parenthesis. Okay, we have to put that the target data type within opening and closing parenthesis. Okay, within opening and closing parenthesis. So if I want to assign int I is equal to 100 to byte b, what I have to do? I have to write byte of I. Okay, this is the type of your target. Okay, but the source type is integer. This is the larger type and this is the shorter type. Okay, this is the shorter type. That's how you achieve typecasting. So, and it has to be, we have to remember that it has to be done explicitly. Okay, other type conversion between compatible types. Okay, that is you have two conditions, right? One is your data source and destination data type should be compatible, and the destination type should be larger than the source type. In that case, Java takes care of the type conversion automatically. You need not have to do explicit type conversion. Okay. Any questions till now? Please let me know if you have any questions. Okay. Okay, Shravanti is asking you a question. Do we come across such situations often, very often? No, we won't come across such situations very often, but not with the these kinds of what do you say? Okay. The question I have pasted it for everyone. Do we come across such type conversion situations? These kinds of, I mean, most of the scenarios, these things are taken care by Java automatically, okay, for primitive data types. But for objects, we will, I mean, we have to, I mean, some situations, those things are also taken care programmatically by something called as design patterns, okay. In such scenarios, we'll kind of like, we'll not discuss about all those things, but in such scenarios, we have to kind of like, whenever needed, we have to kind of like typecast it, okay. Or we will see when we discuss about object-oriented programming and when we start coding in classes, right? We will see those things. But primitive data types, we will not explicitly do it, okay. So, but that's what I mean. Those situations may be very rare, okay, very rare with respect to primitive data types, okay. So let's move on to the next slide. So there is one more situation also. Okay, say for example, you're trying to assign a value of float data type. Okay, you're trying to assign a value of float data type to an integer type. Okay, that is when your truncation happens. So you have for a floating type, you have two things, right? One is your whole number part plus your fractional part. Fractional part, right? One is your whole number part and another fractional part. So when you are trying to assign a float type, it can be float or it can be double, okay, to an int type, okay. Then what happens? Your fractional part gets erased or it gets deleted, okay. That is when the data gets truncated. Yeah, Ron is asking a question, interesting question. So what type is compatible with the char type? What type or so char is so you can tell me, you can think and tell me, Ron. So how, to which data type char is compatible? Okay, that is his question. Okay, so no, char is just a single character. Okay, it is not a string. You can have an array of characters and you can convert that okay, another question Abid is asking. Okay, we will see all these things, Abid, whatever the question that you asked right now. We will discuss about all these things in detail, okay, in today's class. So that is the question which Abid asked, okay, for all your reference. So string is a different thing, okay. String is a sequence of characters. It's in double quotes, okay. String will always be within double quotes, okay. So for example, whatever you write between double quotes, this is string, okay. But when you type within single quotes, okay, that is a character, okay. You can store only one value in a char variable. C is equal to character C, okay. But in string, right, it's a data type and it's an object, not just a primitive data type. This is a primitive data type. We can store only one value in a variable of type primitive, okay. But string is an object. Of course, it has a sequence of characters, okay, within double quotes, but you cannot consider the sequence of characters as a single character, okay. Of course, you can read each and every character from a string as character, okay, but that is not a, this is an object, okay, Java, built-in Java object, but this is a primitive data type. That is the difference, okay. We will see what are the difference, why do we call string as an object or string is a class, and why we have for primitive, why do we call this as primitive data types when we get to classes, okay. Classes is an very the particular session is very important, okay. We need to understand so many things, okay. So that then at that time we will try to understand more differences between primitive data types and then classes, okay. Why do we call these as classes, okay. So it can be removed or the fractional part is completely deleted, okay. When we try to do incompatible type, truncation happens, or you can there is a possibility of complete or partial data loss. We will see that one also, okay, with an example. Can we create our own type? So Ali is asking, can we create our own type? Yeah, so we've been telling, right? So user defined data type is nothing but the types that we create on our own. Whenever we create a class, whenever you say public class, some name, your identifier, what is happening is we are trying to create a data type which is called as user defined data types, okay. There are built-in data types which are similar to our strings, okay. These are Java built-in data types. String is one such an example, Java built-in data type, which is a complex data type. Because we call it as a complex data type, that is why we call it as a complex data type, because it is an object or it's a class, okay. So Pawan is asking, do we have structures in Java as in C#? So let me copy paste this question. Okay, I'm not sure about C#, but I am aware of C, C++, but we don't have any concept of structures in Java, okay. So in C, C++ we have structures, but in Java we have only classes, okay. Class, if you have seen the syntax of class, it is similar to your structures. The only difference is you will have methods, but structures cannot have methods. You will have different data types. You can store different elements of different data types in a structure. That's it. Okay, Abid is asking another question. Can we call every class a data type? Okay, Abid is asking a question. Can we call every class a data type and vice versa? Every class is a data type. Okay, so it can be built-in Java data type or it can be user-defined data type. Okay, I'm talking about only classes. Okay, every class can be considered as a data type. So whenever you say like you are creating a class, okay, whenever you say you are creating a class, you are creating a data type. Okay, whenever you say you are creating a class, you are creating a data type. But not all data types are classes, right? So we have this for simple example is our primitive data type. Whichever primitive data type you take, that is not a class. It is not a class, right? This is not a class. But all classes are either user-defined data types or built-in data types of Java. Okay. Yeah, Anjaneyal is asking, can we convert char into an int? We will see that one, Anjaneyal. Okay. This is the question which Anjaneyal was asking. We will see that one. Okay. So let us see what is this next topic is what is this type promotion. Okay. So as I told, not only the values you can assign when you are doing type conversion. Okay. You can on the right hand side, right? Whenever you are declaring an or you can say you can take an example of dynamic allocation. Okay. So in yesterday's class we saw that one. So while dynamic allocation, you need not have to have a value, actual literal on the right hand side. You can have expression also, right? You can have expression also. So what happens in such scenarios? What happens? See, say for example, I have A and B. I have A and B. Both are of type integers or byte. Okay. So what happens when we try to convert or multiply those two types? Okay. What happens to the type of the result? This is an expression, right? Multiplication is an expression, right? Okay. Multiplication is an expression. In such scenarios, what happens is Java automatically promotes them to respective types. Okay, Java automatically promotes. Note that it is not this one decreasing. It is the promotion from smaller type to wider type. Okay, it promotes. Java automatically promotes. This is applicable only when in case of expressions. Okay, when we are talking about expressions, when evaluating expressions. Okay, we are talking only about evaluating when evaluating an expression. So what exactly happens? Java automatically promotes byte or short or char operand. Okay, byte, short or char operands to integers, int. Okay, so we are talking about byte, short and char. They are automatically converted into int. They're automatically converted into what? They're automatically converted into int. Okay, this explains like the Ron's question also. How we can, I mean, what is char compatible with? Which data type the char is compatible with? It is compatible with your int. Okay, so when this is applicable only in case of. Okay, this is applicable only in case of evaluating expressions. Don't get confused. Okay, this is applicable only in case of evaluating expressions. Otherwise, the type will get converted based on your target data type. Okay, target data type. Okay, so automatic type conversion happens in case of expression. always promotion, not conversion, it is promotion. Okay, happens in case of expression. So when you are doing automatic promotion, it's of useful. I mean, Java automatically takes care of those things, right? It is useful, but there are situations where it might lead to compile time errors. Okay, assume this particular expression. Okay, this particular statement. I want you to analyze this particular statement. Okay, I want you to analyze this particular couple of statements. Okay, we have byte. Okay, we have byte 80, and we are multiplying that byte into 2. Okay, and trying to assign. Is there any issue with this particular statement? Okay, Abhijit is telling maybe error. Yeah, what is the error? So what is the error? What is the error you are seeing? So till now we have discussed something, right? Okay, so 127, no? 127 is the maximum value that you can store it in byte. Okay, let us assume B is 20. Okay, 20 into 2 is 40. You can store it in B, right? You can store it in B. Okay, so why is it? Yeah, Pawan is telling compile time error. Yeah, why is it compile time error, Pawan? Let me unmute you. Yeah, so hold on for a second. I did not see you raising your hand. Yeah, why is it compile time error?
I mean, as you can see, the byte can hold the maximum value of 127. Okay, but the B will be having the value of 160. So in that case, we should
correct. That is for this situation. Okay, that is for this situation.
Right. Yeah. So
but what about
in that case, at least in that case, it shouldn't show any error actually.
Okay, so we will see in an example what exactly happens when we try to do it. Okay, if you can you try to recollect what we discussed a few minutes back? Then you will be able to realize actually what exactly happens. Okay, we will see that in an example. Okay, we will see that in an example. Okay, so we have seen what is a type promotion, and Java does automatic type promotions, but there are some rules which Java follows while doing automatic type promotion. Okay, so we will see that, Pawan. We will try to analyze when we take that example. Okay, yeah, Hug is telling it might result in runtime error when does the assignment happen. Okay, yeah, let's see. Give me a second. I'm just yeah, pasting it. Okay, we will see that when we try to try some examples based on those things. Okay, so here are the rules. So all byte, short, and char are promoted to int. Okay, so when we are talking about promotion rules, we should remember about expressions. We should always remember about expressions. Okay, when we talk about promotions, we should always remember about expressions. Okay, this happens. These rules are applicable only when we are talking about expressions. Okay, that is very important. Otherwise, these promotions will not happen. So what happens? All byte, short, or char are promoted to int. Okay, all byte, short, and char are promoted to int. Okay, if one of the operand is long, if any one of the operand is long, x plus y plus z, okay, and assigning that to some variable ABC. If any one of the operand, for example, let me erase this. Say for example, I have z Okay, x plus y plus l. Okay, if any one of the operand is long, the whole or the other operands will be, the whole expression, other operands are promoted to long, and the result will be of type long. We will see how to check these things. Okay, and then if any of one of the operand is float, the whole expression is converted to float. Okay, if any of the expression is a float, the whole expression gets converted into float. Okay, say for example, you have z v x plus y plus f. Because this is a float, the whole expression is converted into float. Okay, if one of the operand is, if one of the operand is double, the whole expression is converted to double. Okay, the type of the result, the type of the result will follow the below rules. Okay, so long means if any one of them is long, whole expression is long. If any one of them is float, whole expression is float. Double, double. Okay, the result will be like this, based on this one, and this one. Otherwise, it follow this rule. Okay, byte, short, or char will be promoted to int. Okay. Okay, before we go to arrays, we will try some examples. Okay, so okay, so let us see. I want to, so let us see what exactly happens when we try for automatic type conversion. Automatic type conversion. So this is between compatible types. Okay, this is between compatible types. Okay, so what I'm trying to do, byte b is equal to 10. Okay, int I is equal to b. Is it possible? Valid. From 1 byte to 4 byte conversion, right? This is valid. So what about short? Valid. From 1 byte to, is it 2 bytes? Okay. What about byte x is equal to yes? Is it valid? Give me a second. Yesterday, Pawan gave me some trick. Okay, can you all see now? Okay, so we can clearly see that it is showing error, type mismatch. Cannot convert short to byte. Okay, so let us comment this part. We will see. So this is shortening, right? These two are examples of widening conversion. Okay, and what are the other things we have? So we saw, yeah, what will happen if we code like char chx int I char of x? Yeah, okay. So we will take that example. Okay, what Abid is asking. Just copy pasting that question for your reference. Okay. So what will happen? So let us see char t is equal to x, whatever he is told. Okay. So let us try to assign it to int. So is it possible? Yeah, it says it is possible. Okay, we are not receiving any errors. Let us try to print the value of capital X. Okay, that is your uppercase X. Okay. Okay, try to print the value of J. What do you think is the value of J? Because it is a valid one, right? Okay. So the question asked by Mohammed was, what will happen if we typecast it? We will see when we get into typecasting. Okay. So what is the value of J? Let us see what is the value of J. Okay, it is 8. Value of J is not 8, it is 88. Okay. So what happens when you declare a char variable? When you declare a char variable, yeah, correct. It's a ASCII value of X. Exactly, correct, Pawan. So what Pawan is telling, it's a ASCII value of X. Can it be a value of? We told like in Java, you have in ASCII you have a set of characters, right? And each character will have its own values. Okay, I will give you one exercise after this class. Okay, so you try to do that one. Okay, so the ASCII has a set of characters. Okay, all the characters which are there in ASCII, it's a nothing but ASCII character set. We call it as ASCII character set, or we have Unicode character sets. Okay, whenever we talk about Java, it is Unicode character sets. Okay, but ASCII character set, the same, whatever the value, each character will have its own value in decimal number. Okay, how do you get that value in decimal number? Say for example, you have say one character in Java is 16 bits, right? That is 2 bytes. Okay, so whenever you write or whenever whatever you see in our very starting classes, we have seen like whatever you see, I mean the underlying understanding is machine can understand only binaries 0 and 1. So whatever we see on the screen, whatever we see on your laptop, desktop, whatever it is, they are presented in a way that we could understand those things. But behind the scenes, what happens? It is all zeros and ones only, right? So these characters also, each and every Unicode or ASCII characters are also saved in zeros and ones, which can be converted into your ints. Okay, so when you convert that value, that binary into decimal number, this is the value which results for your X. Okay, this is the value which results for your X. It is for ASCII as well as for your Unicode character. Okay. So any questions? Yeah, any questions? Anyone has any questions in this? Okay. So characters, we can directly assign it to integers. Okay. Can assign it to integers. You try other possibilities. Try to whenever you are programming, try to assign character to a byte or short. Okay, character to byte or short, and see what exactly happens. Okay, whenever you try some examples, interesting things, right? If you want to share in the class, let me know. You can share that that particular your observation. Okay, whenever you try something new and you say you feel that okay, this is good to share with all the team members, you can share that in our session. So if you just tell me like you want to share something, you can share it. I'll unmute you and you can share that knowledge, whatever you gained while you are trying to explore more and more. Okay. Okay. Now, so let us see what is typecasting. Okay. So all these things, so the compatible test, what we saw it is taken care by, this is called as automatic type conversion. Okay. Taken care by Java. Okay. But in case of typecasting, we have to cast or we have to change the, this is your word. Okay. This is, or the data type of C is your char. Okay. This is the source. This is the source. Data type of your source is character. Okay. So data type of your destination, that is your integer. Okay. When they are incompatible, we go for typecasting. One simple example is this one. Okay. Let us take the same example. Okay. How do we do that typecasting? We saw the syntax, right? We saw the syntax. What we have to do? Target type within bracket, I mean within parentheses, and then the value, or you can mention the variable as well. Okay. What we can do in this scenario? We can just write like this. What is the target type of target type on the right hand and left hand side of equals? It is byte. Okay. So it is byte. So is it valid now? Is it valid? Are you seeing any errors? No, right? So let us try to print the value of x. What is the value that we get? 10. So what is the value that we assigned it to s? Where is s? Yeah, here is it. Okay, short. The byte value 10 we assigned, and we converted it back to byte. Okay. What happens if int AB is equal to some 40,000. Okay. Byte EC is equal to byte AB. Is it possible? Yes, it is possible because we are explicitly typecasting it. We know the risks associated with this particular explicit typecasting, which happens with respect to incompatible types, right? So we know that, and we as programmers, okay, when we say we, it is programmers. Programmers takes the responsibility of the data loss, okay, that is the risk associated with the shortening, okay, typecasting. Okay, so we are talking about primitive data types. As I mentioned, these kinds of things will not happen so frequently. Okay, so it rarely happens. Okay, so we'll not worry about that. But whenever these kinds of things happen, like it is like the programmer knows what exactly is happening. Okay, then only they will do it. Okay, I have not come across for at least for primitive data types, I have not come across such scenario till now. Okay, so let us try to print the value. BC. So what is the value of BC? 64. Okay, from 4,000 or 40,000 we got 64. So isn't it a data loss? It is a data loss, right? So I want you to, this is the second exercise. Okay, I want you to figure out why the value of BC is 64. Okay, first one is try different combinations. Okay, type conversion. Okay, And if you see any interesting observations, please share it with everyone in next class. Okay. Third one is, why is the value of PC is 64? How do we get this value? Okay, how do we get that value? All these three things. Okay, these three things. Okay, so what else do we have apart from those two things? Marian conversion is done, automatic conversion is done, typecasting is also done. We have seen how typecasting works. Okay, so one more important thing is there. So what Abid asked, okay, that is, okay, so automatic type conversion, type promotion is there. Okay, automatic type promotion is there, and what about the other one? The type promotion. This is the thing with the automatic type promotion. Okay, so what Abid asked. Okay, so what will happen if we try int or okay, what is the character that we have here? C, right? So what Abid was asking is int cd is equal to char of C. So what exactly happens? It is not an issue. I mean, this is not an issue, right? Is it showing it as an error? No, it is not showing as error. Let us try to print what is the value of C. CD, sorry. CD. Let us see what is the value of CD. What is the value of CD? 88. What is the value of J? 88. So what it gives? What it gives? Okay, you tell me what it gives. Okay. How do we get this value? Okay. So how do we get this value? That is one more exercise is check what is character set and what is character set. Okay, check what is ASCII character set and what is Unicode character set. Okay, you can Google it. You'll get all the information in Google. Okay, just try to get information on ASCII character set and Unicode character set. Okay, and if anyone can share it with everyone in our next class, that will be really great. Okay, cool. Yeah, that will be. I mean, it will be like sharing that information with everyone. That's it. Okay, so that will also kind of like help others understand in a better way. Okay, so try all these things. Okay, whatever I'm typing in the chat, right? Try all those things and share it. I mean, if you see there's something interesting you are learning, just share it with your all team members. Okay. So what is the other thing we have? I forgot. Yeah, Pawan is telling. So in case of byte or in case of integer to byte conversion, the last 8 bits will be copied to the byte. Okay, what exactly he is telling is, so if I can write it here, so what he is telling is, so you have say for example you have byte b is equal to byte of some 4,000 40,000. Okay, but we got the result as 64. Okay, when we try to display that value of b, maybe that is a different variable, we got the value as 64. So what is he telling is, say for example this is a integer value, int value. Okay, say for example, all these things are different. This one, okay, by the bits. Okay, so these are your last 8 bits, 1010 or something, 1111, something is there. Okay, some value is there. This is how it is represented. Last 8 bits of your 40,000. Okay, this is 1 byte. This is 1 byte, and there are other. This is second byte, third, and fourth. Okay, 4 bytes are there. So what is this? Is the as I told, this is the least significant bit. This one, and this is the MSB. Okay, so what he is telling is from right hand side, whatever is there last 8 bits, right? They will get copied to this byte because byte is 8 bit long, right? 8 bit long. So this particular value, whatever is there, this particular value is copied to byte. But verify it. And let me know in our next class. Okay, Pavan, try to verify that. You can easily, like whatever the value that you take, right? Whatever the value you take, you can convert it into binary value. So say for example, this is 4,000, right? I mean 40,000. So that 40,000, try to convert it into binary. Okay, in 16 or 4 into 8, 32 bits. Okay, and try to write it in 32 bits. Say for example, you get some value like 10 111 or something like that. This is 8 bit, right? There are other 3 more bytes. You can put it as 0000. Okay, and then see whether when you assign this particular value to 8 byte, do we get the same value? Okay. Do we get the same value in the sense like the like whatever you told is correct? Okay, I'm just verify that one. That will be an interesting thing. Okay, so that's what I wanted to tell. So try to do. I mean, whatever you are answering, right? Kind of like try to explore it, or try to write a simple program and try to assess whatever you are telling is whether correct or not. If it is correct, well and good. If it is wrong, you get to know what how you got that particular value. Okay. Yeah, 40. No, it is like 40,000, right? We got what is the value that we got here? For 42, when we convert, I mean 40,000, when we converted it into byte, we got 64, right? So the question is, how did we get the 64? That is the question. So, but Pawan is telling the last 8 bits of 40,000 is copied to last 8 bits of 40,000 is copied to 8 bits in byte. Okay, he already has the value. He already has done it. So this is what he is telling. So binary 40,000 in binary is this one, this value. Okay, and then so last 8 bit is 64. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 7, 2 power 7 is what? No, 2 power 6, right? So how did you arrive at that one, Pawan? Give me a second. I'll just unmute you. Yeah, Pawan, you can go ahead. 2 power 6. Okay, cool. Yeah. So what about try with this one? What is that? Different values. Okay, try with different values and confirm that. Okay, so you can try different with different values. Are we getting the same value? Okay, are we getting the same value? That is whatever last 8 bits, right? Whether they get converted into your this one, what is that, your whether they get copied into your byte 8 bits. Okay, but we have to remember that all numbers in Java are signed numbers. Okay, so what does that mean? The last bit, right? The last bit or more significant bit will always be used for sign. Okay, 1 is your negative, 0 is your positive. Okay. Okay, so what else do we have? Promotion rules. You try these things. Okay, whenever you put one value which is long, or which is your float, or which is your double, see whether you can you get the type of double. Okay, let's try this one, this particular scenario. Okay, first let us try this particular scenario first. Okay, let us try this one. Byte L is equal to 50. Okay, byte L is equal to 80. So whatever the value you want to take, you take it. Okay, so let us try to print the type of the result. Okay, let us try to print the type of result. Let us not worry too much about the syntax that we are using here. Type of L star M. Okay, is what? Okay, so is it integer dot class dot is instance of L star M. Let us see what is the value. So what I'm asking here, okay, let us try a few more things also. Okay, let us not worry too much about what we are doing here. So I'll just explain what exactly we are doing here. Okay, so what we are doing, we are trying to check whether this is the result. We are checking the result, type of the result, or the data type of the result. Okay, what is the data type of this particular result? Okay, L and M. Okay, so this is a it either returns true or false. What is the data type? Okay, is it an instance of integer? Is it an instance of long? Is it an instance of byte, or is it an instance of short? That's what we are trying to ask. Okay, let us see the answer. Okay, so what is it saying? It is saying first one. Is it an integer? The result is result an integer? Yes. Is it long? No. Short? No. Byte? No. Okay, so the result is, the data type of the result is integer. Okay, the data type of result is integer. So when we discussed about type promotions, okay, when we discussed about type promotion, we saw that whenever within an expression, right, within an expression, byte, short, and characters are promoted to integers. Okay, within an expression, byte, short, integers are promoted to int. Okay, if at all any operand is long, the result of that particular expression will be long. Okay, if at all the one of the operand is float, the result will be float. Double means the result will be double. Type of the result. Okay, it is not the result. It is a type of the result will be that one. Okay, the respective type. Okay, so there is one example which we took, one interesting example. That is what exactly happens with the type promotion. Okay, so byte is 80. Sorry for that. Byte is 80. Try to multiply that with 2. Okay. Okay, so let us try to multiply L by 2, L star 2. So what exactly happens? It is clearly showing it's a error. Can you see what exactly is the error? Type mismatch. Type mismatch cannot convert from int to byte. Okay. Why is this part int? Can anyone tell why this part, the right hand side part is int? This is showing an error, right? Why this particular part is int? what we are trying to do here? We are trying to multiply 50 into 2, which is 100, which we can store it in L, which is of type byte. Okay. Can anyone tell me why that is showing as error? It is clearly saying it is a type mismatch. Can anyone tell why it is type mismatch? Yeah, I will give a chance to Hari Krishna Pavan. Okay. Yeah, Hari Krishna. Tell me what is the issue here. Pardon me, I could not hear you, Hari. No, still I could not hear you, but I will give chance to Pavan. Let me see what he thinks. Yeah, Pavan, go ahead and tell me.
Oh, well, yeah, as you can see that the number of bytes allocated to, number of bytes the byte occupies is 1. Okay, but when you take off 100, it's going to occupy more than a byte. So when you actually convert it.
No, actually, you can store till 127 in byte, right?
Yeah.
Right? 120 till 127, you can store it in byte. Okay, so can you get some information from this particular sentence or this particular print statement?
Yeah, actually L has been promoted to the integer type.
Exactly.
So
Yeah,
we are against
Hari.
bringing it back to the bytes. Is that true?
Yes, correct.
Okay.
So we are talking about expression here, right? We are talking about expression. As soon as expression comes into your mind, or as soon as you see expression, the data type promotion should come to your mind. Automatically it should come to your mind. It is like that the type will get converted, and we have 4 rules, right? So whenever you have normally what happens? Byte int short. Okay, not the byte int, character, byte, and short are promoted to your integers. Okay, and then if at all one operand is long, the whole expression or type of your result will be long, and float and double based on your operand. Okay, so how can you do this? You just typecast it to byte. Okay, then this expression will be correct. What happened? This expression. So we are trying to convert the whole result into byte, typecast the whole result, not just L. So what exactly happens is L is equal to byte of L star 2 means it will still show error. Why? Because this byte or type conversion applies only to this one. Okay, not for this one. Even though without type conversion, the type of L is byte as we defined here. Okay, no need to write the type of typecast byte to byte itself. Okay, even if you try to do that, it will still show error. Let us try to do short. Whether it shows error, of course it shows error, because the expression itself is evaluated or promoted to integer. The result itself is promoted to integer. That is why we can't store it in byte or short. Okay, it has to be stored in integer. So what exactly happens if I try to do this or try to assign this value to int ABC? Right, automatically the error automatically is removed. Okay, so 200. We got the value as 200. Okay, find out how we got that value as 200. Okay, so that is what is about today's class, and we could not cover arrays. We will cover the arrays in tomorrow's class. We will try to cover both single dimensional arrays and double dimensional arrays, 2-dimensional arrays. Okay, in our next class, that is tomorrow. And we will see, okay, in tomorrow's class. Do you have any questions? Anyone has any questions till now? Whatever we covered? Do you have any questions? Okay, let us wind up this session now, okay, and tomorrow we will cover arrays, single dimensional and two dimensional, and we will try to do some how we will see what exactly we can do, like how to access an array, individual elements, how to assign values to individual elements, or whether we can access it using some other means, or all those things we will cover it in tomorrow session. And then we will, if the time permits, we'll go a little beyond also. Okay. Yeah. Thanks everyone. Thanks a lot. I assume I don't have, no one has any questions. If you have any questions, please post it to intuition.java. .com. Post it to the .com. Okay. Yeah, Panindra, thank you. Yeah, that I mean, anyone can send an email. I mean, whenever you have some doubts, just try to send an email to us. Okay. Yeah. Yeah. Thanks, Safia. Sure. Yeah, Pawan wanted to ask some question. Yeah, you can ask me, Pawan. Not in the call. You can ping me. Yeah, good night, Shwanti. Thank you. Yeah, thanks everyone. Thank you very much.